Hello, geometry folks. Do you guys ever get stage fright to where you like stand up to start talking and then you look at the crowd and you're just nervous and you stop don't start talking yet? I get that way sometimes when I hit record on my computer and I just kind of stare at the screen. Normally I edit that out, but this time I thought I'd let it in there. So let's get started. Today's notes 4.3 Pythagorean theorem parentheses length. Okay, so we're going to be talking about length on a coordinate plane, but using Pythagorean theorem. There are a couple different ways to find length. The first one we'll do is Pythagorean theorem. So, our notes, set them up, pause the video, get them all ready to go. Pythagorean theorem can be used to find the length of a line segment on the coordinate plane. So if I have a line segment on the coordinate plane, I can use Pythagorean theorem to find the length of it. We'll show you how. First off, we're going to talk about the Pythagorean theorem just a little bit. You should know what the Pythagorean theorem is. You've seen it in middle school or some other time. The Pythagorean theorem is a squared plus b squared equals c squared. All right, that is only applied to a right triangle. You cannot use the Pythagorean theorem on a non-right triangle. On a right triangle, we have two legs. Okay, those legs are the a and the b, and the a and b can alternate and switch. Those don't really matter. The side that's always the same is side c. Side c is always a hypotenuse. You can always locate that hypotenuse by locating first the right angle. Once you know that this is the right angle, go across from that, and across from that is side C, the hypotenuse. All right? So the Pythagorean theorem works, for example, if I have a leg of 3 and a leg of 4, I can find that leg, find the hypotenuse, which would be side C, by writing it into the Pythagorean theorem. So if we have a squared plus b squared equals c squared, my legs 3 and 4, so 3 squared plus 4 squared equals c squared. Write the whole equation through, okay, and just keep following it down like this. I know 3 squared is 9, 4 squared is 16, and that equals c squared. 9 and 16 together is 25. So if 25 equals c squared, again, I want to find just what c is. Well, the operation to cancel out that squaring something is the opposite of squaring, which is the square root. So if I take the square root of both sides, it gets rid of that c squared. So I'm left over with then the square root of 25 equals c. And then I can simplify this, the left-hand side. The square root of 25 is 5. So 5 equals c, and I want to write that a little better. I want to say that actually c equals 5. All right, using the symmetric property from our proofs. Some people have asked me, okay, do we have to know the symmetric property? No, I'm not really going to require you to know symmetric property, but just know that if you have something equals c, then c equals that same something. So I can write it that way. All right, so c equals 5 in this right triangle. Very popular way to put a right triangle, a 3, 4, 5 right triangle. That's called a Pythagorean triple. We will see that again. All right, example 1, copy this down. We're going to find the length of the segment here. And so finding the length is the exact same thing as finding distance. Distance and length are the exact same thing. In order to find the length of this line segment here, I cannot count it. Do not try and count the length of this line segment. Can't do it. If it was a horizontal or vertical line, you could count this, just count the units. But since it's a diagonal, I can't go across units here to try and count that. That's wrong. What I'm going to do is use the Pythagorean theorem. And so I can only use the Pythagorean theorem on a right triangle. So you might be asking yourself, where's the right triangle here? Well, we can draw it in. We got the side there. I can draw a straight line going down and a straight line going to the right. Look at that. It created a right triangle. And the side I'm trying to solve for is the hypotenuse, the side C. All right? In order to find that, I need to know what the two legs are. Well, I can count those because it's straight horizontal or vertical. So straight up and down, I've got 1, 2, 3, 4. So this length is 4. And then straight left and right, I've got 1, 2, 3, 4, 5, 6. So my legs are 4 and 6. Then we just use the Pythagorean theorem as you already know it. So the Pythagorean theorem, a squared plus b squared equals c squared. A side and b side, doesn't matter which one's which. We have got the 4 squared plus 6 squared equals c squared is what we will have. All right, simplify that out and solve for c. 4 squared is 16, 6 squared is 36, and that equals c squared then. 16 and 36 is 52, so 52 equals c squared. Again, do the opposite of squaring something is the square root. So I have that just c equals the square root of 52. I'm going to write one step here. I'm going to switch the c and the square root of 52. Hopefully you can follow me. Now c is equal to the square root of 52. All right. That is not simplified. I want to simplify that down as we've already done. 52 is the factors of 2 and 26. And 26 can be factored to 2 and 13. So the square root of 52 is actually the square root of 2 times 2 times 13. And there I have my pair of 2's. And so I can bring those outside. So this is actually equal to, bring the 2 out, I've got 2 square root of 13, and that's my simplified answer. A quick note on that, if you put this into the calculator, you're going to get a decimal answer. That decimal answer is approximate. It's not the exact answer. I want to get the exact length of side C there, length of my segment, so I leave it as a simplified radical. I'll leave it as a radical to get the exact answer. Let's do one more. All right, find the distance between the points -6, -4, and 4, 1. So plot those points on a graph. I've got -6, -4, and then I've got 4, 1. I want to find the distance between that. Again, distance is the exact same thing as length. Don't let those confuse you. Here I've got my line segment. All right, so we want to get our right triangle going here. We're going to go up and over to it. I always read my right triangle left to right because when we get to slope, we always read slope left to right. I always want to get in the habit of always going left to right. There's my right triangle. And the lengths of my sides, this is going to be my side C. Length of this side, 1, 2, 3, 4, 5. Length of the left and right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 and 5 are the legs of my right triangle. So I've got a squared plus b squared equals c squared. And so I'm going to put the numbers in there. I've got 5 squared plus 10 squared equals c squared. And 5 squared is 25. 10 squared is 100. And so the 125 equals c squared. And I'm going to do the square root of both sides yet again. And switch them both. So I can do the square root of 125 equals c, and so therefore c equals the square root of 125. I just switch those around because I like to have my variable on the left. Factor out 125, that's 5 and 25, and 25 can be 5 and 5. And you can always double check this when you do this. I want to get 125. What is 5 times 5 times 5? It's 125, so I did it correctly. All right. So underneath I've got 5 times 5 times 5. I've got one pair of 5s, so I can bring those out, and then just 1 5 by itself, so leave that one inside. So this is equal to 5 square roots of 5. Again, we could double check that with the calculator, plug in 5 square roots of 5 in the calculator, plug in your original square root of 125. Does it get the same thing? Yes, it does, so therefore we did it correctly. We found the distance between the points on the coordinate plane. All right, see you guys tomorrow.